Let's look at the Unit 6, Lesson 14, Are You Ready for More from Illustrative Math. So it asks the question, consider a general parallelogram with vertices 0, 0, a, b, c, d, and a plus c, comma, b plus d, where a, b, c, and d are positive. Write an expression for its area in terms of a, b, c, and d. Okay, so I have that here. We can see 0, 0, AB, CD, A plus C, B plus D. And you might be thinking, yeah, I can do length or base here times height here. And I can just say, draw in my height. Oops. I could draw in my height and try to find what that length is. I can probably use the Pythagorean theorem. But here's the thing. I started to do that right here, and that's a lot of work. And the only thing I've done here so far is find this intersection point. I'll talk about this work for a second, just so that you can see where it's coming from. I figured, well, I know I can find this distance using the Pythagorean theorem. So I know that this length is B, I know that this length is A, and therefore this length here is going to be equal to the square root of a squared plus b squared. Okay, great. But then to find this height, I would need to find this length here, and I would need to find this length here. This one isn't so bad because I know that it is the square root of c squared plus d squared. However, to find this distance right here, I would then need to find the intersection point of this new line I created in this line here. Okay, well, I can at least find an equation of this line. I can use point slope form and say, all right, I know it's going to go through the point CD, and I know that this line here had the slope of b divided by a. So that equation, because it went through 0, 0, was y equals b divided by a times x, which means this equation right here would have the equation y minus d equals negative a over b, because I know base and height are perpendicular, times x minus c. All right, well, that's a system of equations right there. So I can solve it by substitution. And I've solved it. Here's x, and I plug it back in and I get y. But quite frankly, I do not want to use this in the Pythagorean theorem. That's just going to be messy. And then I'll have to do the Pythagorean theorem again to find the height. So there's got to be a simpler way. Now, this was looking at it algebraically, so let's take a step back into the world of geometry because that's the class we're in. All right, so here I have the figure again. I've written in a couple of extra labels on the axes. If I know this coordinate is a comma b, then that means my x value right here must be a. If this is the coordinate c comma d, my x value is c, which means if this is the coordinate a plus c comma b plus d, then this must be the x coordinate a plus c. So let's think about this in terms of composition and decomposition. So I'm going to make a giant square around this parallelogram. Okay, because now what I can do once I've made this square is that I can say, that I know the side length of this, let's call it a rectangle because we're not sure it's a square. I know this rectangle has a length of a plus c and it has a height of b plus d. So I can say that the area of this rectangle is a plus c times b plus d. So I'm going to write that over here just so we remember. So I have A plus C times B plus D. All right, and now we're going to do some other stuff with some of our geometry concepts. All right, so let's take a look at some of these other images here. I'm going to start right down here. I've got this giant rectangle here, and I've got my parallelogram inside. I'm trying to come up with the idea that this parallelogram is going to have an area of AD minus BC. All right, let's see how we get there. So I know the big rectangle is A plus C times B plus D. So I'm going to start taking pieces away. So I'm going to make a triangle right down here. Now, I know that this triangle is going to have an area of 1/2 A times B. So I'm going to write that in here. Let's just make it 0.5 AB. Okay. Now, I also know that this triangle is going to be the same as the triangle up here. Okay, except I'm also going to call this 0.5 A times B. All right, then over here, I know that this triangle, I'm going to make another triangle right over here. Okay, and I know that this triangle has a length or a base of C units. I can see if I draw from here to here, this distance is C, which is the same as this distance right down here is C, which is the same as this distance over here. So I know that this triangle has a length of 1/2 C times D. So I'm going to write that in as well. Get my text box, so 0.5 CD. All right. And again, we have the same triangle, just rotated over on this side. That is also equal to 1/2 CD. And then we also have these two little rectangles, which would be equal to C times B. Okay, and we will write those in. And this is C, or sorry, BC. So let's do some math. I know now that my big rectangle is A plus C times B plus D. Well, then the parallelogram has to be equal to A plus C times B plus D minus 2 times BC, because those are the two little rectangles, minus AB, because that's the 0.5 AB and the 0.5 AB, and then minus CD, because that's the 0.5 CD and the 0.5 CD. So what I end up getting when I distribute is if I distribute this right here, I have AB plus AD plus CB plus CD still minus 2 BC minus AB minus CD. And I can start to look at what cancels. I can see that I have an AD here and a minus, I can see that I have an AB here and a minus AB here, so those are going to go away. I have a CB here and a 2BC here, so I'm going to be left with minus BC, and I have a CD here and a minus CD here. So altogether, I'm left with AB minus BC. And that is what I wanted.